which all Canadians will know is what people who do not live in Toronto say about Toronto. So from the centre of the universe, we have Aidan.
Thank you. Well, thank you for having me. I thought Canadians were nice, but I guess I was wrong. I'm just kidding. Thank you so much for having me here. It's such a pleasure to not only be looking at this beautiful view while you're all turned the wrong way, but also to be a part of my first ETC event of any kind. Yeah, so this is awesome, and this is exciting, meeting a lot of people that I've only ever communicated with on the internet, so it's kind of cool to see those people IRL. But yeah, so I'm going to talk a bit about ChainSafe, who we are, what we do, how we started, and then also I'm going to talk a bit about what we're doing and the things that we're working on that are a little bit more relevant to ETC and just EVM-based blockchains in general. And I'll also mention a bit about kind of how we even got to ETC, let alone ETC Summit. So yeah, hello. I was supposed to have that slide on. So yeah, a little background on us. We started at an Ethereum developers meetup in Toronto. It looked like this. It's the only picture I could find of it on the internet because I just didn't care to take a picture at the time. And so yeah, this is where I met my partners, or at least most of them. It was a regular meetup that happened. I mean, this is a big one with a lot of people. It was usually, like 10 of us. Scott was there and a few others from Toronto. And yeah, it was just a place for us to have fun, think about things, and see, can we experiment together? And that's really where ChainSafe came from. It came from a local community meetup. And so this was the first space where we actually rented our own little office. And by rented, I mean we would, book space in the public library and then go and meet there and say, yeah, this is our office. So that was really cool. And it was awesome because it was, we're building open source stuff, we're building things for the commons while taking advantage of our, amazing public institutions in Canada. And so this is one of my partner's apartments. This was our real first office. In his living room is where the real magic happened. And then this was our first real office that we paid rent for. It's right next to our office now. And so this is a picture of our Ethereum developers meetup that we now co-organize. The same thing that we found each other at, we now kind of, with the help of people like Scott, are now bringing that to others. So it's a real privilege to be able to not only kind of be a part of that grassroots community, but to then give back to it and actually create the space that gave us everything that we have today. So what are we doing now? These are kind of major projects that I'm just going to highlight, and then afterwards we'll talk a little bit more about ETC specific. But yeah, for now, so yeah, just going backwards, just one note. These are in the order in which we started them. No one here is a favorite. We love what we do in general. So Lodestar is a TypeScript implementation of the Beacon chain. So yeah, it has incredible tools that we've built out to make this work. The Beacon chain, for whoever doesn't know, is phase 0 of ETH 2.0. Very recently, we had an incredible milestone achievement where we were able to interoperate with a bunch of other clients. And so that means that all the code we've been working on for almost a year now is not garbage and actually really good. Oh, thank you. And so this is a really exciting milestone because, you run spec tests and you run all these different things and they work, but you don't get to see it, right? You don't get that validation, no pun intended, of actually seeing these things talking to each other. And so, yeah, this just happened and it was really, it was really an incredible moment. Gossamer. So Gossamer is a Golang implementation of the Polkadot runtime environment. The Polkadot runtime environment is basically, if you're familiar with Substrate, Substrate is also a Polkadot runtime environment. And what that really means is it's kind of like the base that you would need to then build a parachain. And so a parachain is a blockchain compliant with the Polkadot ecosystem. You don't, however, need to use this framework per se to build a Polkadot blockchain or a pair chain. You could build whatever kind of blockchain you want with it. So it's all the little pieces that you would need to build that. So, you know, it has the networking all there, everything basically there that you would need. And so go Ethereum. So we implemented the Atlantis and Agartha hard forks into Go Ethereum, Geth Classic, which was you know, not necessarily the easiest thing in the world. It was a code base that had been left for a long time. As Afri talked about earlier, there weren't really test nets that existed for us to test this. And something that he didn't mention that happened in the Morden testnet was that there was an issue because of the nonce, the starting nonce. And so, you know, we thought, holy shit, critical consensus issue. What's going on? What's going on? Oh, turns out Morden nonces are different than everyone else. And so, you know, these are real kind of problems that arise because you aren't the person who wrote this code and built this client from the ground up, right? And so, you know, one of the things that I want to highlight here is that open source is only, and interoperability is only as useful as it is usable, right? If we can't work on these things and collaborate with each other because there's a gatekeeper that wrote this, you know, wrote all of this, yeah, it's never going to scale and it's never going to work for most people. So we really need to check our egos and work together to make these things happen. So yeah, Ethermint is Ethereum on Tendermint using the Cosmos SDK. And so what that basically means is that we're taking the EVM, turning it into a Cosmos SDK module, and then eventually it'll be created into its own zone that hard spoons Ethereum. But what I think is even, you know, kind of more usable to developers is the fact that the EVM will be a module. So you as a developer can, you know, take your dApp and scale it into a Cosmos zone that, you know, has optimizations perfectly built for you. Yeah, and this will complement your dApp on Ethereum, Ethereum Classic, or whatever. You know, these things can work together, not necessarily just against each other, as we all kind of usually expect. So yeah, we're really proud to be recipients of grants from all of these incredible organizations. Again, this is in order. Yeah, the Ethereum Community Fund, the ETC Cooperative, the Web3 Foundation, the Ethereum Foundation, and the Interchain Foundation. And so yeah, without these organizations, we would have no work to do. And these are some of our clients that we've worked with. Yeah. So how did we kind of get to this place? How do you start building blockchains? It's kind of like an abstract, weird thing to do for a living. So around 2 years ago, we started looking at implementing sidechains. And so what's a sidechain in the Ethereum context? Because, you know, in the Bitcoin context, this means something different. This usually means merge mining and all these things. But in the Ethereum world, it usually just means that you have a fork of Ethereum that's optimized for a specific use case, and then you bridge that chain over to you know, ETC or the Ethereum mainnet. And the reason for doing this is to allow for your application-specific optimizations to be realized while also kind of allowing you to then utilize this token or whatever across a multitude of chains. So yeah, this is a bridge. You can think of deposit and withdraw as just contracts, and they could kind of go the other way as well. And the bridge instance is sitting somewhere, could be in the cloud, whatever, and it's just monitoring these contracts. So it's a pretty simple design that has been around for, you know, 3 years. It's been implemented, 3.5 years people have been using it. 3 years, it's a bit different than a relay. But yeah, these are things that have been around for a long time. And so what do we have to do to build these Ethereum sidechains? And how did this kind of, I guess, you know, how did we start building blockchains starting with this, right? So we would fork Geth, and a lot of these projects, potentially parity, but mostly Geth. And then we would utilize, at first, we utilized the parity bridge, which was the first kind of piece of software ever built to bridge EVM blockchains. And eventually we realized that people don't like Rust, regardless of what we thought. And our kind of perspective, on the future of programming, I guess it just didn't matter. Again, we had to check our egos and realize that we were building things for people and not subject matter experts. And so Chainbridge was born, which I'll talk about a little bit at the end. But basically, it's just a Golang implementation of the parity bridge. And our clients were really happy with that. It wasn't that much work. And just like that, we made something like a bridge really usable for people. And then they would always want some weird consensus mechanism, so we would try and do that. And so what did we learn from building these Ethereum sidechains? Well, firstly, we need more modular blockchain components. We need clients like Pantheon, which are built for not only just public blockchains, but also for, unfortunately, enterprise applications. And the reason I say that is because, well, not the unfortunately part, you know why I said that. But the reason that matters is because in enterprise use cases, they'll have their own consensus, they'll have their own requirements. And so, you know, these clients made for those purposes are actually built in a more modular way because they assume that people are going to take this code and do stuff with it, right? When Geth was built, it wasn't assumed that someone would fork it and go make an application-specific blockchain, right? It was made to be a public, decentralized, or generalized smart contract platform. And so, you know, finally the technology is starting to actually be at a point where I guess it makes more sense to do certain exciting things. Plus, you have all these incredible frameworks like the Cosmos SDK, Gossamer, and what have you. And for one of the projects, we worked on a sidechain for over a year, added opcodes to the EVM, had to then go justify that all the way up the stack. And from this, over a year of work, dealing with like Geth, Sol-C, Solidity, Remix, the only upstream PR that we ever had was adding Control-S to recompile in Remix as opposed to saving your browser. I don't know if everyone remembers Control-S used to save your browser. Well, thankfully, after a year of work, we were able to fix that. The reason I bring this up is because it's really important to note that the point of open source is not to feel really good and to market this as something that's free for people to use so you can go and do whatever you want to do from a business perspective. The point of it is for people to decide together on standards that we can, as a collective, contribute towards because these are common goods that provide us value that's beyond zero sum, right? Linux doesn't exist because a couple of hippies wanted to build an operating system. It exists because large enterprise has decided that it makes sense economically for them to support this thing. And that's something we really need to appreciate. And it, again, requires us to check our ego at the door to be able to actually take the next steps that are required to take this technology to the world. And on that note, interoperability is only as useful as it is usable. And what I mean by that is that technically I can do whatever I want. But if I can't make this in a way that's usable by other developers, if only subject matter experts can build with this technology, well, then who are we really building for? And will anyone ever use it, right? And, you know, we're all I guess one of the biggest questions I get asked is when decentralized Uber? When decentralized Airbnb? And my answer to that usually is, well, I can't even explain to my friend in 5 minutes how he can get started or they can get started building a dApp because, you know, they would need to basically come work at our company for a couple months before they could do anything. And that's kind of a problem that we don't really address. We don't really address kind of the barrier to entry that it takes to build something on the blockchain today. Now, it's one thing to go build a smart contract, a single smart contract, and then a shitty React UI and call it a dApp. But it's a whole other thing to go interact with state channels, plasma chains, and a whole magnitude of incredible technology that's available today. I mean, most people think that Ethereum right now cannot scale, but that's just not true. Like, we're working on ETH 2.0, and let me be the first to tell you that Ethereum has scaled already and has been scaled for the past 6 months to a year because state channels and plasma chains have been available this entire time, yet nobody has gone ahead and used these things, right? And to me, I think that that just indicates how much the barrier of entry is to using these technologies. And if that was kind of diminished, anyone would be able to build anything, right? Isn't that the point of decentralization? And so how did we begin contributing to and collaborating with the ETC community? Because it kind of started one place, it went to another, and now they're both happening at the same time, which is awesome. So it all began with Gurley and Cody. So we kind of briefly talked about, or Offrey talked about it. This was a hackathon project of ours at ETH Berlin just over a year ago. And this awesome guy, I don't know if you've heard of him, named Anthony, he reached out and wanted to see if there was some kind of potential room for collaboration. You know, he saw that this was something that not only, this is not an Ethereum Foundation mainnet specific thing. You know, this is a problem that exists and persists in our ecosystem, as Offrey mentioned in his talk, right? And so, yeah, this was our first collaboration, and it was awesome. And it was just so easy to get kind of going together and get to work, which was, yeah, really exciting for us because, yeah, I think within like a month or something, we were already working together. Yeah, which was awesome. And so then we began working on Go Ethereum with ETC Labs, partnering with them. And that's been an incredible journey and has been a lot of fun. Getting to know Terry and Eric and a lot of the developers there, it's been awesome. And yeah, I'm excited to see kind of how that journey continues. We have a few hard forks coming up. So yeah, we're excited for that. And it's just been great to get to know everyone and to get to know kind of the motivations for why we're all here. I mean, people honestly want the best for this technology, and that's just always fun from a developer's perspective to kind of build towards, right? Build towards like good intention. And so Besu, this is I think I'm pronouncing it right, I don't know. It's hard. So this was really recent. So this is with collaboration with the ETC Cooperative. So for those of you who don't know, the Consensus Pantheon client got accepted to Hyperledger and got renamed to Hyperledger Besu. And so Bob and Yaz are pushing for ETC support in Hyperledger, which is really cool. And I'll be totally honest with you, from our perspective, something we never expected. I never expected to be contributing to Hyperledger. So it's quite an achievement to actually have that be something that we want to do as Ethereum developers, so that's pretty cool. But yeah, we're contributing to Hyperledger, and soon we'll have ETC support in a Hyperledger project client, which is really cool, really exciting. And so that's kind of, I guess, if the major kind of things that we're working on with ETC. And these are just tools that we're currently working on or have already that are either open sourced, or I'll mention that they will be open sourced, that are relevant to any EVM blockchain. So Anemone is a testing tool that broadcasts batches of transactions and tests opcodes. This for us is really important to feel comfortable with not just Atlantis, but other things that we've done. Like, this doesn't exist. There's no integration testing tool available for Ethereum. That's ridiculous. So this is an answer to that need. And yeah, you can use it today. Node map. So this is coming out of the Gurley initiative. So this is both voluntary and, I didn't write non-voluntary, but it's dev P2P monitoring. So if you know how dev P2P works, you know it's non-voluntary. And the point of this is that we have a lot of different things going on in the networks. It's hard to understand what's going on from a layer 0 perspective. Layer 0 is kind of the networking side of things. And so this will take ETH stats and take dev P2P monitoring and kind of smash them together into one tool. So you'll be able to not only see what people are telling you, but you'll also be able to see what they're telling you. So that'll be a lot of fun to have out there and for people to be able to use and to start caring a little bit more about networking, because it's definitely, you know, cryptography is really sexy, but networking never really got sexy. And so Ultralight Beam. Ultralight Beam is a project that 3 of my colleagues, Eric, Hyman, and Greg, are collaborating with Dean Eigenman from Status. So this is something they worked on at ETH New York. And really, for me, is one of the most exciting things, I think, in blockchain at the moment, because it's relevant beyond blockchain. And so ultralight beam describes a protocol for sending offline messages that will later be broadcasted through relay nodes. It is a transport-agnostic mobile ad hoc network for sending arbitrary data. And so what this allows you to do, and what their ETH New York, and soon they'll have a presentation at DevCon that goes a bit more into detail with examples. But what it did at ETH New York was allow for someone over here who wasn't connected to the network to basically sign a transaction, broadcast that transaction, and then through Bluetooth, propagate it over there. So this is huge in terms of, for sure, offline transactions, but even more important, you look at what's happening in Hong Kong right now. Well, previously with the Umbrella Revolution, Fire Chat was the tool that was used for people to communicate. So this made mesh nets that allowed people to communicate with one another, completely proprietary. They now use that. They license out that software all over the world. This, on the other hand, is just a protocol. Anyone can use it. Anyone can build on top of it. Any blockchain can utilize this, and it's just for arbitrary messages. So imagine taking something like Fire Chat, generalizing it to a protocol, and then allowing for anyone to build on top of it. So now we can have offline messages from any blockchain being relayed by anyone who wants to be a participant in this relay network. And the best part is, there will never be a token. Chainbridge. So Chainbridge is a modular multi-directional EVM-based blockchain. Bridge, wow, that's long. And basically what this allows you to do is set up EVM to EVM bridge. So basically what I talked about earlier, but just, I'm guessing elaborating on it now would be what I should say. But yeah, so this is a simple piece of software. It just allows you to basically deploy a contract on one blockchain or one EVM-based blockchain, and then on another, and maybe even another. Like you can do 3 or 4 blockchains, really as many as you want. And then there's this kind of piece of software that then monitors these different contracts. So yeah, you could have this be like a POA type system. We've worked on versions of it that have had some gossiping between the bridge nodes, or the bridge instances, I should say. They're not really nodes. So yeah, there's lots you can do with this, and lots that you can fork it on GitHub and do whatever you want with it. So that's basically it for my talk. I've been meaning to change the GitHub thing. It's only github.com/chainsafe. If you care about any of the things I said, please go there and look at the stuff we do. I mean, everything we do is either open source or will be open source when we're comfortable with the code quality. Most of our things do start as ideas that are completely public, so with really poorly written code sometimes. No, I'm kidding. We don't do that. And yeah, so just go there, fork whatever you want, do whatever you want with it. Tell us it's broken, because without you, it's useless, and we're just building for ourselves. So please, if there's anything that this talk gets you to do, is just critique our code, please. Because yeah, there's not very many people in the world who care to do that. So hopefully a few of you are sitting in this room right now. But yeah, that's basically it for me. Thank you so much for having me. And thank you, Bob, for inviting me.